start with the textbook. What can I help you work in the textbook? Which one? 16? Okay, you're going to have to speak up and read it out loud. What's it say? Okay, and what intervals are we solving for? Okay. 0 to 2 pi, tangent 4x. Now here's the thing with those, and this is kind of what I talked about. Oh, I didn't get to talk to you all yesterday, right? At all. Right. Okay, so let me sort of, I'm glad you picked this one. This is a good one, Brian. In a nutshell, that ridiculous video that you guys watched the day the sub was here, it was kind of a little wobbly, right? Because I was so tired when I made that video. Kind of in a nutshell, here's the deal. It would be awesome if I could just make this regular old x, but I can't. So, I mean, not without, like, lots of effort, like using some identities and then some double angle identities and gross, right? So what we're going to do instead is, because this is 4 times the angle, I'm going to make this 4 times the interval. 0 times 4 is 0. X times 4 is 4x. 2 pi times 4 is 8 pi. I'm going to change the interval. And then I'm going to ask myself, tangent of what angle gives me 0? So 0 degree, or 0, right? Pi, so 180 degrees, right? 360 degrees. Oh wait, I'm in degrees. Hang on. I need to be in radians. My bad. This is radians. How about this? 0, pi, 2 pi, and we got to keep going. We're going all the way to 8 pi. Yep, it's pretty much every pi, isn't it? 5 pi, 6 pi, 7 pi, 8 pi, and 4x equals every one of those. 4x equals every one of those. So how do you get x by itself? Divide by 4. So 0 becomes 0. Then I have pi over 4. Then I have pi over 2. Then I have 3 pi over 4. Then I have pi. 5 pi over 4. 3 pi over 2. 7 pi over 4. And 2 pi. All of these, with the exception of the last one, fall within our first sort of set of intervals. How come I can't use the last one? Right, this doesn't say equal to. So you actually have 7 answers on this one. Alrighty? Does that make sense, Bryant?
Yeah.
Everybody else? Terrific. Give me another problem. 20. Somebody read it to me.
Sine squared x over 2 minus 2.
Like this? Okay. And what intervals am I solving for, Heather?
0 and 5.
0 to pi. 2 pi, just kidding. Alrighty. We probably want to get, the trig function by itself. So let's add 2 to both sides. Oh, and let me say this. Well, no, it doesn't really matter on this one. Never mind. Forget it. How do I get this sine business by itself? What do I do? Square root, right? Whenever you take the square root of 2 sides of an equation, what do you have to remember? Plus and minus. So I have plus and minus radical 2, right, guys? Yes. So it's saying what angle is going to give you positive or negative radical 2 as the answer for sine. What happens when you type out your calculator? You get an error. How come? Sine only bounces back and forth between positive and negative 1. This is outside of those bounds. So the answer is no solution. That's why that one was tricky. Good question. Great one. All right, what else? Anything else out of the textbook? 36. I heard 36 first. All right, Tiffany, what does it say?
Cosine of theta equals sine squared theta over 6.
Anything else? Okay. And what is the interval? 0 to 360?
But it says give all solutions.
All solutions is what we're looking for. Okay. Alrighty, friends. Let's see here. I believe what we could do is on this, I could make them all just regular thetas. Like I wouldn't have to deal with this half angle, but I'd have to use a half angle identity. Let's just try and kind of see what happens. And the reason I'm not afraid of it is because this says squared. So when you square it, that big roof is going to go away anyway. So it's not really a big deal. So we use the identity. So you check out your pink sheet, and it's going to be big old radical. I don't know, is it 1 plus or 1 minus? I always forget. 1 minus cosine of theta all over 2. That's the identity. That's what it says it equals. And that whole thing, according to this right here, is squared, yes? So on the right-hand side, if I'm squaring that, roof pops off, I've got 1 minus cosine theta all over 2 now. Now what would you do to get theta by itself? Multiply both sides by 2. So I have 2 cosine theta equals 1 minus cosine theta. Now what? Why don't we add cosine theta to both sides? Doesn't that give us 3 cosine thetas? Then what would you do? Divide by 3? So it's saying cosine of what angle is a third? Do we know?
Yes.
Wait, did I do that right? Because I got a different answer. Oh, I did it wrong. That's why. All right, forget that. All right, if we've got, I did all this correctly, yes? Let me just double check. Yeah, I'm good. We don't know, and I believe, doesn't it also say in your textbook something about rounding off so many decimals? The 10th? Okay, so this is one of those ones that you can draw the triangle, but we don't know what that angle is going to be. We don't know what that is. So you can just use your calculator. Should you be in degrees or radians? Degrees because it tells you the interval is between 0 and 360, is that right? Okay, so we type in second cosine of 1/3. Somebody tell me what you get for tenths. 70.5-ish degrees. About. And it wants all solutions. Well, here's the thing. This is positive, so what other quadrant is cosine in besides the first quadrant? Fourth quadrant. So if the reference angle is 70.5-ish, this reference angle is also 70.5-ish. All students take calculus? I see what you're saying. It's because you're solving for all possible solutions, so they're not limiting you to anything. Okay? So if we go all the way around, how are we going to find out how big that angle is? How do I figure it out? Yeah, so 360 minus that answer. So we type in 360 minus second negative, so that types in that answer. What is it, 289.5? And it said all solutions. So don't I want this angle plus a whole bunch of circles, and this angle plus a whole bunch of circles? Yep, so plus 360 in on both of them. Make sure you've got degrees, little degree bubbles, please. Like I said, I don't know what Zangmore's like across the hall whenever you guys step into calculus, but I know my professor counted off every time we didn't have that degree bubble. So I've just kind of gotten in the habit. And there's that one. Does that make sense? Any other questions on that? Yes, sir. When it said it wanted every single solution, Logan, then I know that the angle I need is 70.5, but I need a circle after that, and a circle after that, and a circle after that, because every time I hit that little mark, it's going to give me that answer. You know what I'm saying? Yep. You got it. All right, what else? Anything else from the textbook, or do you want to move to the worksheet? 22. Last one from the textbook, then we're going to move to the worksheet. Heather, what's it say? Just like that? Okay, what's the interval on this one, guys? 2 pi. Yes, ma'am.
Okay, like the interval last one is like between 0 and 360. Then why do you still add the plus 360 in?
Because somebody told me that it asked for all solutions.
It
Asked
does.
for all solutions.
So if it, okay.
Good question. Alrighty, it would be awesome if I could either get these to be just regular old x's, or at the very least, if I could get these two to be the same trig function. Can I get those to be the same trig function? Isn't secant just 1 over cosine? So let's change the left side to say 1 over cosine of x over 2. Alright, now what?
That's where it is.
Well, let me ask you this. What would you do to get x by itself? Multiply both sides by x, right? So how do I get that angle by itself? Multiply both sides by cosine of pi over 2. So 1 equals cosine squared of x over 2. So if this was our problem, then what would you do? What's that thing you called?
Square root.
Just checking, because you've said thingy like 100 times. Just making sure you know it's called square root. So we have positive and negative radical 1, which is 1, equals cosine of x over 2. Now here's the thing. I'm not going to be able to get this to just look like an x without a bunch of trouble. So I think what we need to do is we also need to half our interval here. Half of 0 is 0, half of x is half of x, half of 2 pi is pi. Let's solve for this interval first. 0 to pi. So for one of these equations, it's 1 equals cosine of x over 2. The other one is negative 1 equals cosine of x over 2. But we're only solving between 0 and pi. So from here to here. Positive 1 is going to be over here. Well, actually, this is a quadrantal, isn't it? I shouldn't have even drawn that triangle. Sorry, that's confusing. If cosine's a 1, isn't that right there? 1 comma 0? What angle is that? 0. So x over 2 equals 0. And that's kind of it for that. What about negative 1? What about this guy right here? Isn't this negative 1 comma 0?
Oh yeah.
Cosine comma sine? So it's 0 and it's also pi, right? What's the problem with 0 and pi? Doesn't say equal to, right? So your answer is 0. And 22.
So the parentheses means that it doesn't include that.
Correct. Yeah, the parenthesis means it goes all the way as close as you can get to it without actually being that number. Right, and then you would multiply by 2. Sorry, I just did that in my head. So multiply both sides by 2 and you get x equals 0. Sorry. Still 0. All right, so that's book stuff. Let's transfer over to the worksheet. Alrighty.
7.
7 it is. Let's do number 7, everybody. Yep, she's on top of it. Alright, what's it say, Ashley?
It says 1 minus 2 radical 2 is like right next to it. Times sine of x.
Sine of x what? Times cosine x?
Yeah.
Okay,
It has to be equal
thank you.
of 0 to 1.
Okay. I think this one just weirded you out because of the radicals, because this one really isn't that bad. We're trying to break these guys down and get them by themselves. Let's see here. I'm going to subtract 1 from both sides. Most of you probably started out doing that. And then you kind of freaked out. This means -2 times radical 2 times sine times cosine. How do you undo all that times? Divide. Let's divide both sides. Now be careful. I don't want to like mess with your old brains, but think about this. If I divide both sides by negative and radical 2, if I leave that 2 there. Ah, somebody caught it. I'm only going to divide by the negative radical 2. Negative divided by negative is a positive. 1 over radical 2 rationalizes to radical 2 over 2. And somebody over here goes, oh, what is this? It is an identity. For sine of 2x, it's a double angle identity. Now, I'm not going to be able to undo this 2x business, so I'm going to have to double this interval over here. So I have 0 to 2 pi. What angle for sine is going to give me radical 2 over 2? Well, pi over 4, right? And is there anywhere else that's going to give me radical 2 over 2? Think about it. All students take calculus. We already took care of the first quadrant. Isn't sine also positive there? 3 pi over 4. There you go. That's 3 pi over 4. All right, both of these fall within 0 to 2 pi. There's 4 that work from 0 to 2 pi, but I got to get x by itself. What do? Divide by 2, which is the same as multiplying by a half. So pi over 8 and 3 pi over 8, and those are your answers. Yes, sir.
On the second one we wrote, is it 0, 2x, and 2 pi? Yeah.
Yep, thank you. Sorry, thank you. Good catch. Anything else? All right, give me another one. 20 on the worksheet. Oh, you would pick this one. I started this one last night and realized I screwed it up, so I quit. It was too late. It was like 10 o'clock at night, and I was like, forget it. Okay, 6 sine squared theta plus 5 sine theta. Let's see if I can do it right. Equals 6. And it's from 0 to 90. Whoops, not equal to. My bad. It does have the equal this time? Thank you. So I did not make that up. Okay, I'm looking at this. And I'm thinking, I see something squared, something not squared, and then like just a constant. Sounds like it's a quadratic to me. So let's write sine of 6 squared theta plus, oh, I did this one last hour. I just remember that. So subtract 6. It's okay. It's a good one to do. This one is factorable. So I'm going to use 2 sine theta, and I'm going to use 3 sine theta for the front, because that's going to give me 6 sine squared theta. On the back end, if I put a 3 here and a 2 here, 3 times 2 is 6. I need different signs, and I need a positive 5 in the middle. So positive 9 sine minus 4 sine is 5 sine. So that's just factoring. Break them apart. And I have 2 sine theta plus 3 equals 0. 3 sine theta minus 2 equals 0. On the left, sine of theta. Does it freak you out if I just put negative 3 halves? You know where I got that, right? Subtract 3 divided by 2. On the right, sine of theta equals 2/3, yes? Do we know anything that does any of those things? We do not. This is where the calculator comes into play. So grab a calculator. We need to be in degrees, it looks like. And I type in second sine of negative 3 halves, and it's probably going to come up an error. How do I know that? Right, it's not between 1 and negative 1. So that's done. Let's just deal with this guy right here. See ya, have a good day. Second sine of 2/3. We have 41.8. Does it say to round to the nearest tenth or what? What does it say? 2 decimal places, so 81 degrees. And we're done, right? No! Or There is another answer. Do they want it?
No.
No. They said from 0 to 90, guys. So you're done. But if they said 0 to 360, Ocean, then sine is also positive in the second quadrant, which Ocean means that this is 41 point whatever over here. So take 180, subtract that off, that gives you that angle. Alrighty?
Okay.
I've got time for maybe one more.
22.
15, 22, which one?
Whichever one's fine.
15. Somebody else said 15, so we're going to do 15. 15, everybody. Tangent x equals -2 sine x. And it's from 0 to pi. This looks fun. I don't like the way that I did that last night, apparently. You want to do sine over cosine? Okay. Let's try it.
Good morning, Owasso High School. Quick announcement before we break for first lunch or head to fourth period. Seniors, just a reminder, representatives from Jostens are here. They'll be here till 3 o'clock after school. They're set up in the Performing Arts Center.
Divide by sign.
In order for your cap and gown, you made announcements. You had any Native American student. We also have Mrs. Foster from Education here as well, and she will work with you on the stipend that Indian Education provides for your cap and gown. So if you've not signed the Indian Education sheet, she is there. Make sure you check in with her to sign that document. Thank you.
Okay, so I divided both sides by sine of x, but be careful, guys. When you cancel things out that have x in them, sometimes you miss a whole solution. I happen to know on this one you're not going to, but be careful, because you could just like, poof, a whole solution sort of disappears. So be careful. We have 1 over cosine equals -2. If you want to make that secant equals -2, that's fine. Or you could make this cosine and then divide that guy by 1 also. So, or 1 divided by that guy also. It doesn't matter. Flip one or the other. Let's see here. So we've got -1 over 2. It's the 1, 2 radical 3 business. What angle is that? What? It's not 30. 60. So it's pi over 6 is tucked in here, which makes that one 5 pi over 6. But you aren't finished. It also is negative in the third quadrant, 7 pi over 6. And that's what it's looking for. Alrighty, there you go. Go ahead and get all packed up. Make sure I get my books back.